Okay, so today's lecture is about relations and function. What is a relation? What is a function? What makes a relation a function? Okay, that's the big thing. Okay, so this was given at the beginning of the chapter, in which we did not even talk about, but let's just look at it. It's showing yearly closing prices of gold. At the beginning of the chapter, the closing prices are given in the following table. So here we got 1966 all the way to 75, and the closing price of gold. What do you notice about that closing price? Yeah, it goes up quite dramatically, right? Okay. So here they graphed the same data in two different graphs. One is with the closing price on the y-axis, and one is with the year and the year on the x. And then on the second one, they have the year on the y-axis and the closing price on the x-axis. Okay? So there's two different ways of looking at it. Each of these graphs, sets of ordered pairs in their graphs, show the relationship between the variables. What are the variables? It's x and y normally, but look at these particular ones have a different name. Y and p. Okay? So in this case, one of the graphs, the y is in the x place and the p is in the y place, which is a little confusing. But remember, y is year. You might want to just even put above it year and price. Okay, so year just happens to start with a y. Okay, so moving on down, we want to look at what a relation is. A relation is any set of ordered pairs. In the relation YP, graphed on the left, no two ordered pairs have the same price. Each value of y relates to one and only one value of p, and a relation having this property is called a function. Okay, so a function is a set of ordered pairs x and y in which each first component x of the pair is paired with exactly one component of y. So let's look at two examples of that. I'm going to look at, I'm just going to put it in this margin right here. 2, 4, 1, 3, 3, 5, and 2, 3. We have relations here. I want to know if this relation is a function. Can you tell me, is it a function or not? Well, the first thing you need to look at is look at your x values. Okay? We have a 2, a 1, a 3, and then, what do we have? Another 2. It's repeated. So notice that because the x value is repeated with two different values of y, this one is not a function. Okay? So that's the way you're going to look through. If the x value is repeated with two different values for y, it's not a function. So moving on here, it says dependent variable, or y, is the output. It relies on the input, which happens to be the independent variable x. Normally we look at something and it'll say y equals 2x plus 3. Usually when you have a variable on the left side of the equation, that's the dependent variable. And the one on the right side where all the stuff is happening to it, the input, that's the independent variable. Now, does it always have to be an x and a y? No. Okay. All right. So when a relationship between two quantities is a function, we say that the dependent variable is a function of the independent variable. In our gold example, the price of gold, which happens to be the second component, is a function of the year. And this is important. Not every relation is a function. Just like what I showed you up here. That is not a function. Still a relation, just not a function. In this example here on the right, we've got a right triangle, and we know that the sum of all of the angles equal 180. We also know that these two angles here add up to be 90. So we can come up with this sentence here of x plus y equals 90. If I were to subtract x from both sides, I would end up with this equation. Here, the x is the independent variable, and y is the dependent variable, because it depends on what x is to be able to determine what it is. The same could be said for this isosceles triangle. These two angles are equal, therefore I could write the sentence being 2x plus y equals 180. If I were to solve this by subtracting 2x from both sides, I would end up with this equation right here. Here, the x, again, is independent, and the y is dependent. Moving on. Example 2b. Or 2a, sorry. The percentage P of the adult U.S. population aged 25 and over who have earned 4-year college degree by the year Y is given in this table. So they give us the years and they give us the percent. It says, is Y a function of P? Why or why not? Okay? So let's look at Y and let's look at P. Is there any repeats of P in here? Yeah, right here. Okay? So this would say no, because P equals 21 in 1990. Oops, should be 9 there. And 1992. In other words, they're saying P is the X value, Y is the Y value here. Okay? And we have a repeat of X here in this case. But if you look at part B, if you look at it this way, where Y is the X value and P is the Y value, is that a function? Yeah, it is, because there's not any repeated Y's. So this is yes. So I want you to take a minute, do the same type of thing for example 2b, and we'll check it in a minute, okay? So in this example, if you're looking at y as a function of p, that means p is in the x part, y is in the y part. Look at the p's. Are there anything repeated? Yeah, right here, correct? So since there's something repeated, it is not a function. However, if you look at part B, if you reverse these, y and then p, is there ever a year repeated? No. So this is a function.